Let's define the key points in this problem. The focus of the standard parabola y squared equals 4x is s at a, 0. Any arbitrary moving point P on this parabola can be represented using parametric coordinates as at squared, 2at, where t is the parameter. Let M with coordinates h, k be the midpoint of the line segment joining the focus S and point P. Applying the midpoint formula, the x-coordinate h is the average of the x-coordinates of S and P, and the y-coordinate k is the average of their y-coordinates. To find the locus of point M, we need to eliminate the parameter t. From the y-coordinate equation, we can easily isolate t as k divided by a. We also rearrange the x-coordinate equation by multiplying both sides by 2 to get 2h equals a times the quantity t squared plus 1. Now we substitute t equals k over a into the rearranged x equation. Distributing the constant a and rearranging the terms allows us to express k squared completely in terms of h. This simplifies cleanly to k squared equals 2a times the quantity h minus a over 2. To finalize the equation of the locus, we replace the specific midpoint coordinates h, k with general Cartesian variables x and y. This reveals the locus is another parabola. Comparing this to the standard form capital Y squared equals 4a capital X, we can determine its vertex and scaling factor capital A, which is a over 2. The directrix of a standard parabola capital Y squared equals 4a capital X is given by capital X equals negative capital A. We substitute capital X with x minus a over 2 and negative capital A with negative a over 2. Solving this gives us x equals 0, which means the directrix of our locus parabola is simply the y-axis. Hello there. Excellent question. We used the midpoint formula simply because the problem specifically asks us to find the locus, the path, of the midpoint. In locus problems, our goal is to find an equation that tracks a specific moving point. Since we are tracking the point exactly halfway between the focus $s, a0, and the moving point $p, at $2, 2 at, we use the midpoint formula to find its coordinates $h, k, $. Once we have